Good afternoon, I'm Mr. Ish. Thank you for joining me. Important physics concept here, not a long video. We're looking at clearly the distance and displacement. What is the difference between these two very important terms? Let's talk about this. This right here represents let's use the word net change in position of an object. And you can understand what that would be when I give you everything with regards to an initial and a final position, initial position, and the difference of the two. Where an object is and where it was, or where an object was and where it is now, the difference in those two positions is your displacement. What about distance? If you have to use a keyword here being the position, how can you bring that into this? How about this? The total change in position of an object. And why don't we bring in everything here with regards to absolute value? You know what absolute value means. If you have something here in terms of meters, 100 meters, and you have something here plus minus 50 meters, this is absolute value, this is absolute value. When you're looking at it, what you really have is 100 plus 50. This has become a positive and you have 150. That's what I'm talking about, absolute value. The absolute value connotation applies to distance. It does not apply to displacement. But when you're looking at everything right there with the definitions I've given you, it kind of is clear. Displacement is your net change in the position, difference between final and the initial, and this is your total change in position. Look at everything by means of these examples. You have a circular running track, it could be 1 mile. If you start over here and you end over here, a person who has run this in terms of distance has done 1 mile. That's the distance, but in terms of displacement, you've done 0 miles. Why is that? Because here your original position represented a start, let's just call that a start, and your final position also represented a start because you ended exactly where you started. Your net change in position is 0. Where you started, where you ended, the object is in the same location, and you're looking here at a displacement of 0 but a distance of 1 because there's a total change in position of 1 mile. You can kind of grasp the difference between these two terms. How about if I present to you everything here now by a second example? I'm only showing you 3 examples and they will clearly define everything you need to know with regards to these two very important physics terms. If an object is moving north and it moves north 20 kilometers, then that object turns around and it moves down, let's say 15 kilometers. You can see you have 2 opposite vectors, a vector pointed north and vector pointed south. In this instance, when you're looking at the distance, the total distance, let's abbreviate it, you have 20 plus 15, it's equal to 35. But when you're looking at the displacement, you're looking at the net change. Here you're thinking about vectors. You have a vector that's in one direction 20, but it's opposed by a vector coming in the exact opposite direction. Now your displacement is really only 5 kilometers because you're looking here from your initial position to this point, and that's just a 5. You have a displacement here of 5, but you have a distance here of 35, the total change in position. But how can we bring the absolute value connotation here with regards to the distance? You can. If a opposite vector is always represented as a negative sign, you're really looking at, in terms of distance, 20 plus the absolute value of your opposing vector. You're looking at a 20 plus 15, hence you have 35, which is exactly what I have for your distance. Now this right here represents something which is going in an opposite direction. You could have a cumulative effect. This is not my third example, this is just a continuation of the second example. The example of this will be the end. If you have an object that's moving east, let's just say 20 meters, then it moves another 10 meters. Now in this particular instance, your distance is equal to your displacement because there's no effect over here with regards to opposing vectors. You have a total distance here or a total change in position of an object, 30. Here's your resting point, here's your final point, here's your SF, here's your SI. The SF here represents 30, your SI here represents is 0. 30 minus 0 is 30 because the object went in the same direction. There's no opposing or cancellation effect. 20 plus 10, there's no negative here. You can say you have 20 absolute value plus 10 absolute value is equal to 30. That's your distance, but this is also your displacement. No vectors cancel each other out. So in some cases, distance and displacement are always equal. In some cases, but in most cases, they usually are not. Before I present you the third example, keep this very important point in mind. Distance can take the values of a 0 or a positive. If the object didn't move at all, it's 0. But if the object moved, you know there's some movement, it's positive. Displacement can take the values minus, 0 and positive. If the object didn't move at all, there's no net change, displacement is 0. If the object moved everywhere in single direction, you'll have positive values. Based on vector computations, you can have negative values also based on how things canceled out. So keep in mind, displacement can take 3 values, distance takes 2 values. Lastly, look at this final example. You have an object that moves east, let's say 30, then it moves due north, let's say 40, and I'm using an easy example simply because I don't have a calculator on hand, at a 90 degrees. What is the displacement? What's the distance? Well, let's look at the distance. The distance here is the total change in the object's position is 30 plus 40. There's no vector over here that's canceling each other out, so you're getting 70. We can use meters. We don't have to worry too much here about the units, but 70 meters, miles, kilometers. What's the displacement? You're gonna look always from your initial to your final. Here's my initial, here's my final. You'll take the shortest route. You'll do the hypotenuse, and here your displacement will be 50. This square plus this square is equal to that square. You use the Pythagorean theorem and you have 50. You see the difference? You could have had a situation like this and it takes an angle over here. You got 30 here, you have 40 here. You have still a 70 distance, but here you have to calculate the displacement. And then in these type of cases, you would know what this angle is, but you would have to use the law of sines or the law of cosines or some sort of trigonometry to determine displacement. The calculation of distance is straightforward. The calculation of displacement usually involves vectors, usually involves trigonometry, or sometimes straightforward arithmetic operation. So keep everything I've shown you in mind. Displacement is net change in position. Distance is your total change in position. Thank you for watching.